Okay, this is just going to be a quick video to give us an understanding of equivalent equations. So we're not going to necessarily do any tasks for this first part. It's just want us to give us a visual representations of why we have equivalent equations and how we actually create them, just to give us a better understanding before we move on to the task. So the first thing you need to make sure you understand is that equivalent equations are equations which have the exactly same solution. So think back to when we've done equivalent fractions. Okay, so they look different, however they still have the same value, and that's effectively what we're doing here with equivalent equations. So sometimes two equations essentially express the same thing. For example, x plus 5 equals 14, x plus 6 equals 15, and x plus 7 equals 16 are all made true by the same value of x. All we've done is added 1 to both sides of the equation. So here we have x plus 5 equals 14. I've added 1 to the LHS and I've added 1 to the RHS, and then I have x plus 6 equals 15. Again, I add 1 to the LHS and 1 to the RHS. I get 7 equals x plus 7 equals 16. So I've still got the same value for x. I've just done different things to that equation from there. So to give you a better visual representation, we like to think of equivalent equations as scales. So here we have this is our initial equation, and we have this formula or this equation. We have x plus 5 on the LHS equals 14. So as you can see on this scale, if we use this symbol here in the middle as our equals, we have our LHS equals the same as our RHS. So it just looks different, and we have different representations of that. Because it's balanced, we know that our LHS is the same as our RHS. Now, if I just say I subtracted 3 from both sides, so if I got rid of 1, 2, 3, and then I change that to 11, that would look like this one up here, and it's still the same equation. It's x plus 2 equals 11. It is the same because the x value stays the same. What if instead of subtracting 3, I added 1 to both sides? So here I added another one, and then I added another one here. It would look like this equation. So again, it is an equivalent equation because it looks the same, the x is the same and the value is the same on the LHS. Or for example, instead of the initial equation, I doubled both sides, it would look like this. So in each of these cases, they are equivalent equations because x equals 9. So if you went ahead and then substituted x into each of these, you'd still get the same result. X is the same value in all 4 of these equations. So it's just about creating equivalent equations by doing the same to the left-hand side and the right-hand side, and also doing the same to create equivalent equations. Now, the best way to give you a demo of that would be this. I'm going to get you to sort of explore this website here for a while. So it's giving you a different example of how we can balance by adding and subtracting from both sides of an equation. So what you can do here, make sure you read the way how to do that. I'll put the link in the OneNote for you to explore. What you need to do is try and get that you have x on one side and equals what x equals. So you've got to manipulate both sides to try and adjust it so we have x. So I know I've got 4x's here plus 2, and then I have 3x and 4. So I want to start to subtract and add different ways so I can be left with just 1x, and which will tell me what that answer is. So here, okay, so if I get rid of these 2 here, I'm going to take away 2. Okay, that still balances my equation out. So now I have 4x is the same as 3x plus 2. So if I know that if I can get rid of these 3x's here, that would leave me with 1x. So if I go get rid of those 3, what I've done is I've worked out that x equals 2, and I still have a equivalent equation. So explore this website, make sure you read the instructions of how to do that, and then you can go on to the next video. Thanks, guys.